Assalamualaikum warahmatullahi ta'ala wabarakatuh. In this video, I will show you how to do a simulation using the software Autodesk Inventor. This is the example of the simulation that I'm going to demo for today. This is what we call cantilever beam for bending. As you can see from the video, there is a bar, and at the end of the bar on the left, it is stick on the wall. But at the right side of the bar, there is a force applied to the end of the bar, and it is going downward. On schematic perspective, this is the diagram of the cantilever beam for bending. It is important that you are able to convert or translate from this diagram to this free body diagram for you to understand what is going on for bending. To do this simulation, I will be using the software Autodesk Inventor. To get this software, please visit the link above, Autodesk Education Edu Software Overview, and you need to create an account, an educational account, so that you can download the software for free. I will be putting this link in description below so for you easy access. If you scroll down, you can see that this is the software that you need to use, what we call Inventor Professional. And then there is another add-on or extra module that you need to download in order to use the simulation. It is called Nastran. Inventor Nastran, CAD Embedded Finite Analysis Software. So there are two software that you need to download in order to do the simulation using Autodesk Inventor. So let's move to the software. So this is the software. Let me start from the beginning. So once you open the software, create new, and then this window will pop up. Click standard and click create. And then click this button over here, sketch. Make sure you do 2D sketch and click this one. When you click 2D sketch, the software will ask on which plane that you want to draw the sketch. So we start with the Y and Z plane. So click Y and Z plane and then select rectangle. Before you proceed further, please ensure that the unit that you are using is millimeter and not inches. So just draw a simple rectangle over here with a dimension of 25, width 25 mm, and press enter. So press this button over here to have an overview of the sketch that you have done. So far this one is quite good. Click finish sketch. And then click the home button over here to see the object in isometric view. And then the next step is that you need to extrude this sketch to become a 3D object. Under the 3D model tab, click extrude. And this mini window appear. Change the distance A to 250 and press OK. Again, press the home button to put the object into isometric view, or you can press this view over here, is the same. This is the basic shape that we want to use in our simulation. Once you already install Autodesk Inventor and the Autodesk Inventor Nastran, go to environment and click this button over here. If you do not install Autodesk Inventor Nastran, the button will not appear over here. There is a simpler method, stress analysis, but in this assignment, I would prefer if you can use Autodesk Inventor Nastran. Click on it, and then the software will create a new option on the left. You can see that part analysis, units, and so on. And it is easier if you go on the top tab. Under Autodesk Inventor Nastran tab, there is a few processes that you need to go through in order to run the simulation. First of all, click the material that you want to assign to the object. This window will pop up and select material. And then select Autodesk Material Library. And for this example, you can use stainless steel. Just scroll until S, and then you can select this stainless steel and click OK. And make sure the type is isotropic, meaning that the properties of the material is consistent throughout the product, and click OK. And then go to mesh setting, and then click generate mesh, and then click OK. So you can see that on the body of the product or the shape that you draw, there is a net of 5 lines. So this is the mesh that you have generated using the mesh setting option. Of course, there is a lot of option that you can play around, but for that one we'll be using it maybe much later. Now go to constraint. As if you still remember when I show you the example of the cantilever beam, on the other side of this bar there is a wall, and this end is stick to the wall. So this is what we are going to do. We are going to tell the software that at the end of this sample supposed to be stick on the wall. So put it like this, and this is the end that we want to stick to the wall, and click constraint, and this window will appear, and select fixed, and select the surface over here. So one face 6 appeared, meaning that we already select this area and select OK. And then select home to view the isometric of the sample, and this area will be applied force. Select load, and then select the area or the face that you want to apply the load. The face is selected, and in this case you need to key in the load that will be applied to the sample. Pay attention to the axis X, Y, and Z over here. Y positive is pointing upward, and the one that we want to have is Y positive, Y pointing to the negative direction. So this one should be negative 500, and select OK. So now you can see at the right side of the sample or the drawing, there is a green arrow indicate the direction of the force applied to the sample. So now you can click run to start the simulation. You have to save the file first. This one, just put it as simulation example, and click save. Just give the software a few minutes depending on the complexity of the simulation. It may take a few minutes. Click OK, and you can see that the simulation is done, and you can play around with the view. You can click front over here to see the changes of the shape once it is applied a force of negative 500 Newton. At the bottom left of the screen, there is some option that you can play around or you want to explore. If you want to check on the displacement, just check on the displacement. And you can also see more option for you to explore. Just go for the stress in this example. And you can also do animation in this option, in this software. Click this function, animation or animate. So wait for the software to load the option, and you can see how does the shape or the object experience the stress applied to the sample. So you can go for option if you want to do a few more manual editing. So number of frame you can maybe increase a little bit to 50. and select animate. And then right click on the analysis, and from here you can select the option generate report and select OK or select yes. Give the software a few minutes to generate the report. Okay, do it again if the report doesn't appear. So this one you can key in the information that related to your assignment, and the summary, assumption, group definition, contract definition, mesh. And this is the thing that I would like you to key in manually. Please do not use the one generated by the software. Structural loadings, structural support, and also the solution. And this one, just click next and finish. And it will ask you where you need to save the file. Okay, so the report was successfully generated and you can view the report. So this is the report that you have done. From my opinion, the cantilever beam bending simulation is one of the easiest example for students to apply and to use in your study. So this is the before simulation, some assumption, and then this is the meshing, the force applied to the material, and you can also see some of the result. So I hope you learned something in this video, and I hope you can try to do the simulation in order to understand the concept of simulation. So I wish you all the best. Thank you very much.